Hello, everybody. Welcome back to Planet X News. It is June 11th, 2017, and we're here this Sunday afternoon with our Planet X physicist. Doctor, how are you today?
I'm fine, thank you, Scott. And you?
I'm doing pretty good. Very worried about what's happening right now with our other live stream that we just had, kind of an urgent live stream.
Yes.
We were showing everybody all of the information that's pouring in right now with our magnetosphere, magnetopause, solar wind, the whole 9 yards, earthquakes just popping all over the world right now. And it's a very, very urgent situation. And we're going to be getting into some of that later on. But ladies and gentlemen, the doctor has prepared a report on asteroids and meteors. And last year in 2016, it seems like we had a record year for near Earth objects. And going into 2017, it's been, well, I don't want to use the word calm, but not as active as it was last year. However, we have had quite a few near Earth objects, and we've had some small meteor impacts. There was just one in India about 2 weeks ago, a 9-pound meteor. It did land, it did hit in an open field, and they were actually able to recover a large portion of the meteor. But ladies and gentlemen, you know, these meteors, the threat of asteroids, you know, this has always been a very serious, what's the right word? It's always been a very serious threat to our planet. And, you know, moving into the investigations and the research into, you know, Planet X and the possibilities of these brown dwarf stars changing the orbits, perturbing the orbits of asteroids and meteors that have been in orbits for hundreds or thousands of years, this is a very high possibility. Now, we all know or have seen the video footage from 2013 in Russia, Chelyabinsk, Russia, when that large meteor exploded about 15 miles above the surface of the Earth, causing a lot of damage to buildings. People were hurt by flying glass. And that video, well, those portions of video have made it around the world, and they were absolutely spectacular. And we were very lucky to have many, many different angles from all over Russia when that meteor exploded. Now, there are some theories that the meteor was, well, detonated by man on purpose, so it would not impact. And then there are others that say it just exploded 15 miles over the surface. I guess we'll never really know for a fact, but the bottom line is that was a pretty sizable meteor coming in at approximately 25,000 miles per hour, and it did impact in fragments over, I believe, like a frozen tundra and a frozen lake, and they were able to get fragments from that Chelyabinsk impact, but we really never heard anything after that. So we're always under the threat of these meteors and these asteroids. And just a few weeks ago, a team of Czechoslovakian scientists and astronomers were making some observations and doing some research into these meteor showers that we periodically go through. After their research, they basically came out and they said, listen, we are under a greater threat than what was known before, what we thought before as a threat. Now the threat is actually greater based on their published research. And I've always said that, no, we're not going to have a planetary collision with Nibiru or Planet X. if any collision occurs, ladies and gentlemen, it will be with a meteor or an asteroid. Let's hope it never is a comet. But out of the three, listen, they can all do very, very serious damage. Very serious. We all know that. You don't need myself or the doctor to explain to you that a big impact in a major city will be absolutely devastating. Now listen, NASA and other space agencies, they miss these asteroids and meteors. When I mean they miss them, they go undetected, they slip under the envelope, and the next thing you know, there's no time to warn anyone. That was the excuse given for the Russian meteor in 2013. They claimed they did not see it because it was coming from the direction of the sun. Therefore, the sun's light and glare blocked their vision, blocked their detection. Well, this happens a lot. So that's why the fear and the threat of an asteroid impact or a meteor impact, God forbid, a comet impact, would be devastating. But we wanted to go into the article, and the doctor did a great job writing this report on short notice. And we're going to go ahead and get right into it. And let me go ahead and pull this information up. And here we go.
Yes. Thanks, Scott.
There you go,
I
doctor.
actually remember I wrote two reports. There's this one where I explain the differences between comets and asteroids, and then there's the other one that I wrote just on asteroid impact.
Okay.
Yeah, so we're going to go through both.
I'll have to dig the other one up. I'll have to find
Okay.
it. I don't think I downloaded that one.
Okay. All right, so let's get started then. So these objects that we call comets, asteroids, near-Earth objects are all rocky objects. And they are in the solar system, and they can potentially impact the Earth and cause some problems. In fact, severe problems. Okay, so here I explain what is the difference between these objects. Asteroids are objects made up of a combination of rock, carbon, and metal. Different percentages for different asteroids. And these are orbiting the sun. And comets look similar to asteroids, but they develop tails. Well, at least one tail. Most of them have two tails. Some of them actually have three tails. And they usually have one that's a dust tail and another one that's called a plasma tail. And the plasma tail is caused by ion exchange between the particles surrounding the comet and the solar wind. And then there is another category which we call near-Earth objects. And these are both asteroids and comets, but these have orbits that bring them close to the Earth. So here we see in this picture an asteroid passing close to the Earth. And then lower down we see the comet. You see that it has two tails. The blue tail is the plasma or ion tail, and the other one is the dust tail. Now the ion tail always points directly away from the sun. The dust tail can point in different directions. Then what happens for us to see that plasma tail is there's an interaction between the ions in the solar wind and the particles which are neutral in the gas surrounding the comet. So what happens is electrons in the solar wind hop well, it can happen either way. So we can have an electron from one hopping onto the other, say the an ion, which could be a proton in the solar wind. And it starts off at a high energy level, and then it cascades down to a lower energy level. And then when it does that, a photon is emitted. And this photon we see, if it's emitted with a frequency that corresponds to visible light, we then see it as visible light. So for example, that blue one would be emitting light, photons with a blue light frequency. And that's how we see those. Now, there are trillions of small objects in the solar system, that is, smaller than planets. And these could potentially collide with the Earth. But the ones that can cause serious damage are the ones that have a diameter that is greater than 1 kilometer or 0.6 miles. And of those, there are between 1.1 and 1.9 million. And then the near-Earth objects, these are objects that have orbits that bring them close to the Earth. There are 10,000 that have been discovered, and more being discovered all the time.
10,000.
Yes. Yes. And of those, 10%, so what, 1,000 are larger than 1 kilometer in diameter. So, and there are probably a lot more. These are just the ones that have been discovered up to now. And I'm not even sure how old this data is, but yeah, we're getting more all the time. And that's already quite a large number, 1,000. So I think the increasing number of near-Earth objects has to do with the fact that we have all these brown dwarfs in the solar system, and they've brought in debris. And or they moved through the Kuiper Belt and brought in even more debris than they already had outside the solar system. Either way, they brought in a lot of debris into the inner solar system. And this is, I think, why we're having so many near-Earth objects. Okay, so we can move down a little.
Okay.
Thank you. So here is a map by NEOWISE. So this is a spacecraft that has mapped up the objects in the solar system. The white and the gray ones are asteroids. So most of those, we don't categorize them as near-Earth objects because they don't come that near to the Earth. So we're mainly interested in the green and the blue. Those are near-Earth objects. And okay, and the yellow, the green and yellow, sorry. The green are the asteroids and the yellow are the comets. And in the blue, we see the Earth's we see the orbits of the planets. So Mercury, Venus, Earth is in that greenish, well, it's cyan, and then Mars. And then we get the asteroid belt. Okay, now why we are interested in this? Because an asteroid impact or a comet impact on the Earth can cause severe damage, which we can discuss in the second article. But what happens is we get a shock wave, we get extreme shaking from the region where the impact occurs. We get a fireball which just incinerates everything in its path. And then there's dust going into the air, which causes severe climate disruption. So that's why we're so interested in this, because it is a danger that we face. So let's move down a little bit more, Scott.
Oh, don't tell me that's a space rock.
Oh no, this is a meteorite. Now there is a difference. There is a difference between asteroids and meteorites. The asteroids, when they impact, they are vaporized. And a meteor is actually what you see flying through the atmosphere. It becomes a meteorite when it strikes the Earth and it survives the impact. So this one we're seeing right here was a meteor flying through the air. It was burning. It burned up as much as it could in the atmosphere. And this is the piece that was left. And this piece is made out of solid iron. And it weighs 66 tons. And its dimensions are: length is 3 meters, the width is 3 meters, and the height is 1 meter. So it's a big rock.
Yeah, that's a big rock.
And
that's what I meant by space rock. Anything that's flying
yes.
out of space, regardless of what its composition is, unless it's a comet. I just refer to them as space rocks. And that is a big rock.
It's huge. You're right. This is the biggest meteorite ever found. It's this one. So
where did they find that? Do you know?
No, I can't remember where now. I should have looked. I read it, but I cannot remember now. I should have put it in there.
Huge.
It is huge. It is. Now, the other thing that has found, and that Scott actually mentioned to me because I hadn't looked that up yet, is the fact that some meteorites actually have fossilized bacteria in them. And that is very strange, because that would mean that either they come from a planet that once had life on it, or parts of planet Earth got blown out into space and it's coming back as meteorites. It's one of those two options that we have. So as you can see, it's very short. It's just an introduction for to explain what all these different objects are, the terminology, and so on. So we have comets, asteroids, near-Earth objects, meteors, meteorites. So all of these, I tried to explain what these were with this article. So to summarize, asteroids are objects in orbit around the sun. Some of them do come close to the Earth, and therefore they become what we call near-Earth objects. The same thing happens with comets. They often come from outside the solar system, and then they get grabbed by the sun. They move in their orbits. Some of them become sun diving comets. That is, they go straight for the sun. Some of them manage to go around and come back. But they develop tails. And then we have the smaller ones that are usually parts of comets and asteroids, and these we call meteoroids. And then when we see one fly through the atmosphere, and it's usually with looks like a fireball because it's on fire because of the friction in the atmosphere, we call that a meteor. And then if it survives the flight through the atmosphere and it impacts the surface of this planet, and it survives that impact, we call it a meteorite.
I'm still amazed.
And that's it.
I'm still amazed at the size of that rock, and it was recovered. And it looks like, looks like probably a lot of iron and rock melted together.
Yeah.
And that is a big rock. I mean, I could only imagine that impacting the Earth at between 25,000 and 50,000 miles per hour. That would devastate. That would devastate anything. I'm going to go ahead and pan back up here.
Okay.
Let me jump out of this screen. And you said that you had another article. You did email that to me, correct?
I did, but I can email it to you right now again if you like.
I will go ahead and fish it out of my email real quick. Yeah, ladies and gentlemen, earlier, whenever we had our urgent live stream, me and the doctor were going over some information like we do every day on the magnetosphere and the solar wind. And we were going through the information because we like to keep ourselves updated on it. And immediately we saw these abrupt changes in earthquake activity. And I was just reviewing some earthquake activity 1 hour before, and it seemed kind of moderate. And then all of a sudden, boom. I mean, earthquakes everywhere. Okay, let me see here, doctor.
I've just sent it to you again, Scott.
Okay. Yeah, it hasn't come through yet. It will make its way through.
Yeah.
Yeah, and as we were reviewing that data, we saw these issues occurring immediately with the magnetosphere, the solar wind. It was really, really intense, and we're going to go ahead and go into some of that here shortly. Just waiting for my computer to update. You know, it's pretty bad when your cell phone is faster than your new computer. And here it is.
Yes.
It finally popped up.
Okay. Sorry, I should have reminded you of this before we started.
No problem. I'll have this pulled up in just a second.
Okay.
Okay. And we will exit out of the comet report, and I will pull the other report up right now. Okay, this was the expected effect of an asteroid impact.
That's right.
All righty then, let's move right on over to here. Let me share this screen for everybody real quick. We'll pull this up. The doctor could go ahead and go through this. All righty then, can you see my screen?
Yes, I can, Scott. Thank you.
It's all yours.
So, thank you. So we start here. In the first image, we see an asteroid in the upper atmosphere. So it's on its way to impact. So what we usually call the asteroid the impactor, and we call the Earth the target. And the impactor can enter at different angles between 90 degrees and 0 degrees with respect to the Earth. So at 0 degrees, we would get what's called a grazing impact. But the most likely impact angle is actually right in the middle between 0 and 90 degrees, which is 45 degrees.
Okay. I didn't think I have my screen sharing there. It should be sharing.
Okay. It's okay. So now the speeds that these objects are traveling at are between 11 kilometers per second, which is 25,000 miles per hour, and 72 kilometers per second, or 161,000 miles per hour. And they will slow down a little bit when they fly through the atmosphere. And that's because they will encounter severe friction. So Scott, if we move down a little bit more.
Okay, let me just pan down here. Oh, that's a big crater there.
Yes. So a lot of them get vaporized in the atmosphere. We dropped it, or they break up into different pieces. Small asteroids never actually reach the surface, but larger ones will, and then they cause what's called an asteroid impact crater. And we see a large one there. And that would have been a very large asteroid indeed that hit there. So usually asteroids with a diameter of about 150 meters or 492 feet survive this type of impact. It's not a hard and fast rule. It's just an average. So we could have some asteroids that are a bit smaller and do actually manage to impact, and some that are larger and are completely vaporized. So it's just to give an idea of what kind of objects usually manage to survive the flight through the atmosphere. But this is for an asteroid that's mainly made out of rock. If they are made out of iron, then smaller ones, say with a diameter of about 50 meters or 160 feet, do manage to survive. So if we scroll down a little bit more.
Boy, I'm really amazed at the size of that crater. I've seen that crater before, and I've read about it. I've read about it before, and
yes.
Boy, if you were anywhere in that area at the time of that impact, I would say, as we say here in America, you would be SOL, shit out of luck.
Yes, I don't think you would have survived it. Let's put it that way. So what happens when an asteroid impacts? We get a transfer of kinetic energy, which is the energy due to the speed of the object hitting the Earth or the target. So what happens is both are heated to very high temperatures, and they are compressed to very high pressures. And then you get a shock wave that propagates from that point of impact. And the shock wave is produced at the boundary between the compressed and uncompressed material. So as you know, it's very hard to compress a piece of rock, but the impact is such that even rock gets compressed with this the kind of force that is developed. So here we see the shock wave. There's an asteroid impact, and the white ring is the shock wave traveling outwards from the point of impact. This shock wave is extremely destructive. Now what happens is the target, when it hits the ground, it fractures the ground. So the ground gets extremely heated and it shakes for large distances, several radii away from the point of impact. And the cavity forms. So if we scroll down a little bit more, the first crater is called a transient crater. It's not the final crater. There's a transient crater, which is much deeper. You see in the diagram here, the first crater is deep, and then it settles down due to gravity, and we end up with a shallower crater. And some of the material that's removed from this cavity ends up around the rim. That's why you have a lifted rim around the edge. And then you get more material further out, but not as much. And sometimes we have big rocks coming out from this cavity, and those big rocks can cause secondary craters. But there will be a large amount of debris that will come out of this crater, and the finer material will end up in the upper atmosphere and cause other problems.
You know what I wanted to ask you real quick, looking at your photograph here of the shock wave.
Yes.
You know, one thing that just crossed my mind is we're talking pretty much about these impacts on land.
Yes.
You know as well as I do, if any of these space rocks impact, say, for instance, in the middle of the Atlantic Ocean,
Mm-hmm.
what occurs at that point?
Yes. So what you get there is the shock wave when it travels through water is called a compression water wave. So basically what it creates is a huge tsunami. But it's actually better to get hit in the ocean than to get hit on land, because in the ocean you don't get large amounts of dust going into the atmosphere. Because when you have an asteroid landing on land, this is what happens. You get such a huge amount of dust in the atmosphere that although a lot of people can survive, they will die later on because sunlight will not be able to get through the atmosphere. And so you will get, the plants will die because they need photosynthesis to produce energy. So it will cause severe disruption of the climate. I mentioned a little bit later about the hydrological cycle.
So,
But this is what
basically, I
happened.
mean, anywhere we get hit on this planet, whether it be, a large impact in the water, large impact on the ground surface, it's going to be a bad day on Earth.
Oh, yes.
It's going to be a
Very
really
bad.
bad day. These photographs that you have, these even have me a little startled, thinking about this, because I always think about meteor impacts and asteroid impacts. Whenever I started researching Planet X many years ago, I read so much about these objects coming through the Kuiper belt, asteroid belt, causing what is the word? Is it perturbations? Perturbing these asteroids that have been in a specific orbit for a very long time.
That's right.
And ladies and gentlemen, it's nothing for these asteroids to be perturbed or disturbed their orbit, and the next thing you know, that near Earth object becomes an impact. And we saw a situation like this a few months ago where they stated, NASA and the JPL, I forget the name of the asteroid, the name and number, but it's a very large asteroid, huge. And it had been in the same orbit for hundreds of years, is what they said. Now, how they would know that, I don't know. That part of their story, to me, did not make any sense. But they then stated that this asteroid will be coming close to Earth for the first time in 400 years of its known orbit. That didn't make any sense to me. And then further in the article, they were not sure why the asteroid's orbit, after that much time, why it changed. So this is what I'm warning of. We have a threat of a rogue space rock just coming out of nowhere. But then we have these other large asteroids that, these Czechoslovakian researchers and scientists, they were looking at all of these large, very large asteroids. And they basically came out and they stated, they just stated this not too long ago, that our threat is much greater than what is being told to the world population. And the fact of the matter is, with brown dwarf stars or any other type of substellar objects moving from far out in our solar system, Lord only knows what disturbances they would cause and what they would bring in. And going out through 2016, there is no doubt that we saw a major, major increase in near Earth objects. Without a doubt. It's all been classified right on the JPL Near Earth Object website. And we were watching them back in 2016, at least one or two a week. Now, things are a little different going into 2017, thank God, but anything can change at any time. 2 weeks ago, there was a meteorite impact in India. They recovered a 9-pound space rock. Luckily, when it impacted in a field uninhabited, and they were able to recover large portions of this 9-pound space rock, and they were going to be analyzing it, but I haven't been able to find any update on the story or the information that they've recovered so far. So there have been instances around the world over the years. There was one instance, I don't know exactly where it was, a meteorite went right through someone's house. There was another instance where a meteorite hit the back of an individual's car and completely destroyed it. And then there was the only living person on the face of this earth, a woman who was hit in the shoulder by a small fragment, a little meteorite. So we're always being impacted. There's always space debris, particles, things of that nature coming in through our Earth's atmosphere. But what we're talking about is the threat of something that would impact our planet and just wreak havoc around the world. And it is definitely something to keep in mind. I wish we had an absolute known defense against these objects. I think that world space agencies and governments, I kind of believe that they do have something to protect us. But after 2013, watching the meteor explode over Russia, like I said, some will say that it was exploded by man before it impacted the ground. And some will say, no, it just exploded about 15 miles above the Earth's surface. And I know, Doctor, you definitely think that the Russian meteor was definitely exploded by man.
Mm-hmm. I really believe so. I think it was very strange what happened. You can actually, some of the video taken, you could actually see it looked like a beam coming up behind it. So when I saw that, I thought, oh yeah, they're using a beam to explode it. So that's why I really believe that.
It's definitely possible. I believe they have some of this technology because, I've seen the reports and the documentaries on this big, gigantic, jumbo jet airliner that the United States government has, that has a very massive, very powerful laser beam on the front nose of this jumbo jet. They call it the death ray. And it has the ability to produce a massive death ray, a massive laser beam that, I mean, if it's coming out of a jumbo jet, it's got to be big. And if you're going to get hit by that laser beam, well, you're dust.
Yeah.
Now, something that's very interesting that you have up here now is asteroid impacts and this fire.
Yeah, if we look at figure 5, so you scroll down a little bit, so let's look at the fireball first. I mean, scroll the other way. Yes, thank you. So you see here what happens. You get the shock wave, and then you get a fireball forming. And this fireball is basically vaporized material. It's a hot plume of vapor, and it is extremely hot, and it just ignites anything in its path. So if you have a forest nearby, that's why then we can look at the figure below. We see that it just, everything goes up in flames as the fireball expands from the point of impact. So you get everything. This is what would happen to any trees in the area. It also destroys any wildlife. Anything in its path is just vaporized. It's extremely dangerous.
You know, speaking of these fires, now last year there were a host of wildfires in the Midwest. I believe it might have been Colorado. And these big wildfires were completely unexplained, meaning what ignited these wildfires? And it just so happens I was looking into the story, and it just so happened that I was reviewing some fireball data from the Meteor website. And it showed 130 sightings of a fireball in the sky over the vicinity of where these wildfires started right after the sightings of the fireball. So there was no defined impact. However, if you think about it, and I discussed this with Chris Potter also, just think if these smaller, hot, burning fragments did land in forest areas where it was very dry, that would definitely cause the beginnings of a wildfire, and we would probably never even know. Then, in the state of Florida, 2 weeks later, this occurred again. Wildfires in the state of Florida, and just before the wildfires were ignited, there was the sightings of a fireball. Then, firemen that were working on putting out the blaze found a large, very large truck-size divot, crater in the ground, and they found what they thought was a meteorite. But the story was capped, meaning it did make it to the media on the internet, but then it was like hush hush. You know, no, that's just a rock. No, it just burned. And then quickly the rock was removed and you never heard anything about it again.
Yes, very strange.
But I know, it's just my feeling that, you know, when we see these fireballs, there is a very high possibility when all of a sudden we see these massive breakouts of these wildfires, and they could be devastating. The people out in California, you know, they go through them all the time, and in the Midwest, and also in the state of Florida, when they have these very dry seasons, and sometimes they don't know what started the fire. Was it man that started it, or was it, you know, a freak of nature? But last year I caught 2 occurrences where fireballs were seen over the area right before the fire started. And these were both 2 situations of devastating forest fires. Just my thoughts.
Yes, I think it's very interesting. I mean, that's actually very plausible that it was caused by meteorites landing and starting the fires. And that would be more likely if the forests are dry. So if there hasn't been a lot of rain, it's even more likely.
Yeah, I mean, you know, if you think about it, if I took a rock, just an ordinary rock here on Earth, and I put it in a, you know, in a kiln, and I heated it up to, what do you think the temperature? What are the temperatures of these rocks once they break through the atmosphere?
Well, that I'm not sure, but I would think
several thousand degrees.
Oh, yes, I would say so. Several
So
thousand.
if I took a rock, just a regular rock I find on the street, and I heat it up to a couple thousand degrees,
Yes.
and then I throw it into a big pile of dry grass, what's going to happen?
Yeah, it will ignite a fire, of course.
See, I'm learning so much physics from you.
You are indeed. Yeah. Right. Um, so yes, so these are the forest fires, extremely destructive and very bad for the animals that live in there.
Oh, I feel bad for
And
the animals when they get stuck in
yeah,
that does break my heart. There's something I wish there was something that I could do, but
yeah,
nature is going to be nature.
that's right. Scott, can you scroll backward a little bit? Yeah, I just need to mention there. So the shock wave travels at hypersonic speeds, and that is speeds greater than the speed of sound. So faster than 330 meters per second, actually quite a lot faster than 330 meters per second, which is 740 miles per hour. So the shock wave is very fast. Now, there are actually three types of shock waves, depending on what kind of impact we have. So the shock wave in the air is called a blast wave. The shock wave through the earth is called the ground shock. And the shock wave through water is called the water compression wave, which I've talked about already. And the ground shock will cause elastic waves. So actually, it's like earthquakes. And so that will lead to violent shaking of the impact region and up to a large distance, several radii away from the impact site. So if we scroll down a little bit then, Scott. So this is what happened in 1908. This was discovered somewhere in Russia, in an area called Tunguska. And what we see is flattened trees. Now, after you have the blast wave, this is what can happen. Because even after the blast wave, after that you get very destructive winds. So it's not just the blast. After that, there will be very strong wind blowing. So it's not just one destructive event. It just keeps on happening because of these winds. And so what can happen is it can demolish infrastructure, buildings and bridges. Animals, vehicles can be pulverized by the shock wave.
Yeah, that Tunguska,
And
that was like devastating. I mean, I think there are still areas of Tunguska that are still flattened like this, even to this day.
That's right. That's right. They are.
Nothing grows. It's like barren wasteland.
That's right. Nothing grows there. It was extremely destructive. People are not yet very sure what actually happened. They think that the asteroid exploded in the air. But just an asteroid exploding doesn't actually explain why there's nothing growing there. So there's still an open question about what happened there.
All these years later, too.
Yeah. But this is what we would expect from the shock wave. We would see things like this happen where all the trees are flattened. And then beyond that, we can get the fireball, which means they would become charcoal as well because of the fireball. But in this case, they were just flattened.
Yeah, that almost reminds me of what it looked like when Mount St. Helens blew up. It just flattened everything for miles. The trees all bent over. Just a devastating, devastating situation. And again, ladies and gentlemen, these events have occurred on our planet many, many times before. that, a large comet or asteroid was the reason for the dinosaurs becoming extinct.
Yes.
And to tell you the truth, I think dinosaurs are cool, but I don't know if I would want to live with like a Tyrannosaurus Rex roaming around,
No.
or like these big, massive meat-eating creatures. It's bad enough that we're in the beginning stages of the zombie apocalypse, but to have these big dinosaurs, that'd be pretty wild.
Yes, indeed.
So do you believe in that theory, though? Do you believe in the theory of, a large comet or asteroid wiping out the dinosaurs?
Well, I think it's a possibility, but I'm not sure they've been wiped out completely. I think there's the Loch Ness monster that seems to be a dinosaur.
Yeah, and Bigfoot.
And yes, so I'm not so sure. I think there is also pottery from a few centuries back where dinosaurs were drawn. So it seemed that some people that, I don't know, a couple of thousand years ago, it could have been that there were still dinosaurs around. So I'm not sure I believe that the Earth has been impacted by asteroids and it probably destroyed whatever wildlife was there. But it's possible also that some of those dinosaurs, possibly the smaller ones, did survive and continued to live.
I did watch a documentary that was based on man did walk with the dinosaurs. They both lived and cohabitated on this planet at the same time. I truly believe that. I truly believe that. And as I was watching that documentary, I was thinking to myself, wow, what a terrifying time that must have been to be, ancient man, and then, having to deal with these massive creatures. It was a very interesting documentary. I think it was on the Discovery Channel. I watched it, or no, the History Channel. It was like about 2 hours long, and it was very, 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 very impressive because they did come up with some solid evidence that man was here. Man was here with the dinosaurs, but just thought I'd point that out.
Yes, thank you. Well, I agree with that because I've also come across some information about that. And I also think that there were dinosaurs around, possibly not that long ago, and man was around and actually used them and managed to live with them. I think not all of them were that dangerous. Just a few were carnivorous. Most of them were herbivores, like most of the antelope and so on that we have nowadays.
Yeah, I'd hope so. Yeah, the only one I wouldn't want to come in contact with would be that Tyrannosaurus Rex. I remember seeing that.
Yes.
I remember seeing that the fossil skeleton of a Tyrannosaurus Rex at a major museum in the city of Pittsburgh as a kid. I remember standing next to that full skeleton of a Tyrannosaurus Rex. And I think at the time I was big. I was as big as maybe one little toenail on this creature's foot.
Oh my. That's amazing.
Very interesting. I'm going to go ahead and pan down here.
Okay. So, so what happens is, besides all this destruction, we have all this dust going into the upper atmosphere. So if we get an impact by an asteroid that has a diameter of 10 kilometers or more, then the dust that goes into the atmosphere more and will cause more destructive effects than the largest volcanic eruption that has ever occurred on this planet. because there will be so much dust going into the atmosphere. And that will lead to drastic cooling of vast portions of the Earth's surface, and it will disrupt the hydrological cycle, which is the cycle of evaporation of water from the ocean surface. And then it condenses, it forms clouds. The clouds are carried by wind, and then rain falls, and then water flows into rivers, and from there into the ocean. That's the hydrological cycle. So that will be severely disrupted because in some areas, because of the dust in the atmosphere, there will be cooling. And when there's cooling, there's less evaporation. So there will be less rain. Whilst in other areas, there will be more rain because the dust in the atmosphere causes clouds to form. So it helps with the condensation, and there will be more clouds and more rain. So what will happen is in some areas you will get no rain where you were having rain before. And in other areas where you didn't have much rain before, you now get severe rainfall and flooding. But now just imagine what I'm describing is what actually is happening on Earth right now. And I think that has a lot to do with the geoengineering. I think we did a live stream on that. It's putting so many particles in the atmosphere. So I think it's probably doing some of this as well. It's causing some areas to cool down too much, and so there's less evaporation, whilst in other areas the amount of particles is causing more clouds to form and therefore more rain to fall in certain, because it has to do with the winds as well. The surface winds, they will carry clouds to a certain area, and then those areas will get more rainfall.
You know, I have a hypothetical question.
Mm-hmm.
Just hypothetical.
Okay.
What would the impacts be if a large car-sized meteor or asteroid impacts in the center of a major city? Like New York City. Let's just put New York in there. Let's do a movie right now. Large impact in the center of New York City.
Yeah. Okay. That I wouldn't say it would destroy the whole city, but it will destroy a large portion of the city. I mean, it will probably cause severe damage to the buildings around there. It will break the glass. The blast wave will break the glass. It can create fires. I would say it could probably destroy a couple of blocks of the city. You know, all that glass in those buildings will be flying out. So that would cause a lot of people to get hurt. There will be severe shaking as well. So it will be like an earthquake. It depends. I'm not sure it's strong enough to actually demolish a building, but it would at least cause severe damage to a building if it did impact it.
Now let's talk about a large meteor impact off of the coast of a major city, such as New York. You know, maybe let's say 50 miles, 100 miles off the coast, impacting into the ocean, into the Atlantic.
Yeah, what you get is a extremely fast-moving tsunami that just floods and destroys everything in its path. So, so it would destroy everything in the city because the compression wave has so much force that every building it impacts is totally destroyed.
Yeah, that would be definitely devastating. You know, I know they had a meteor impact. I think it was last year, or was it this year, right off the coast of Australia.
Mm-hmm.
Was it off the coast of Queensland? I think it was either late last year or early this year.
Yeah.
And a lot of people got it on video from inside of their homes, and it impacted at night. But as the meteor was flying over, it was creating sonic booms. And these were like actually recorded by people with their cell phones. They heard it coming. Some people described it as, sounded like a freight train. Very, very loud, very, very loud sonic boom. And then it just cruised right over the entire country of Australia and then disappeared into the sea, never to be found again. But I guess it was a smaller meteorite. So, ladies and gentlemen, the fact of the matter is, it definitely occurs. The threat is there. And scientists around the world are now stepping up to the plate a little bit. And they're admitting that the threat that we do have is greater than what is being told. And that's the point of our live stream today. We all know that meteors, asteroids, and comets exist. But what's being told to the world population, that's what I want to get after. How big is the threat? Well, it's a big enough threat for it to be at the top of the list for NASA and space agencies around the world to try to figure something out as a defense mechanism, something that they would literally put up in space as a satellite type fixture, something more of a detection. But then again, they have to test it. They have to actually test this on an asteroid or a meteor or a comet. So we really don't know if they've actually done this or not. I know they crashed a space probe. They crashed a space probe into, I don't know if it was either a comet or an asteroid, to get some feedback and some data. But it really makes you wonder. There have been so many theories that they've come up with on how to disturb or perturb the orbit of a massive asteroid coming in. Just a little bit, just to make it pass by the Earth. And then they were coming up with this one theory of using the sun's light. And then they came up with this absolutely ridiculous theory of painting with paint, painting the asteroid. I think it was black. So the rays of the sun would be more absorbing into the surface, therefore changing the trajectory.
Oh my goodness.
No, this is serious. They thought this. They thought this up. And when I saw that, I'm like, okay, I want all my tax dollars back. You people at NASA are absolutely off your rocker. We know that you're using crayons and Sharpies and magic markers to hide things on the stereo images and the Secchi images. Now you want to spray paint an asteroid black. So the sun's light absorbs into it more and then gradually deflects it. Yeah, forget about it. But yeah, when I heard that and I read that information, I thought, wow, these people must be crazy. But what I wanted to do, Doctor, real quick, I wanted to pull up some of this this information that we saw earlier on the magnetopause. And I'm going to go ahead and share my screen here real quick because I recorded all of the information for us real quick, so we didn't have to worry about internet issues. So I'm going to go ahead. I'm going to go ahead and share my screen here real quick, and you could definitely give us your thoughts on this because what we were seeing was very, very interesting.
Oh my. You
Now,
see
now,
how this it,
now,
bounces.
since we talked, this updated a little bit.
Uh-huh.
We didn't see the compressions of the
Okay.
magnetopause. Now, with this
Wow.
updated footage, you're going to
Oh,
see it.
oh my goodness. It's just bouncing backwards and forwards. Huge amounts.
Now, ladies and gentlemen,
Wow.
we just recorded this a little while ago whenever we did our urgent live stream,
Oh
because me
my.
and the doctor were
Oh,
looking at this information and we said, holy hell, look at this.
yeah.
Now, I knew we were going to have, some type of a solar impact beginning today on June 11th, but I didn't realize how bad it was going to be.
You
And I've
see,
never seen this before. Have you, doctor? Have you ever
no,
seen
I've
anything?
never seen it before because the bow shock is going way too far out. But this, don't forget, I've been saying this, we both been saying this, there is an opposing stellar wind. So there's another star blowing its wind, so its particle flux from the night side of the Earth, from the other side, opposing the sun. And then this is what happens. It just blows the it's unbelievable. I've never seen it move that far. Yeah, it just pushes it the other way in the opposite direction that the solar wind is pushing it in. And this is possibly what's causing the magnetosphere to open up because it's getting weaker. It's getting hit from both sides.
Yeah, I'm glad I recorded this. I'm glad I recorded this because I captured this probably minutes after it occurred.
Wow.
And, NASA's been known to get this information removed and then they replace it with the model that looks normal. So we've already caught them, 2 months ago? Pete from WHDC over in Europe, great YouTube channel, great research. He caught the this information a few months ago, and then they replaced it all. NASA took it down, replaced it, and made it look normal. So they falsified the damn information.
Yes, it is. It's shocking that this kind of thing is happening because this is totally against what science is all about. Falsifying data should in physics, in science, is criminal. You realize that?
Yes, absolutely.
And basically this is what they are doing.
Now I'm going to bring up the magnetopause here, and this was once again, I actually was able to catch the updated information, and then I went back hours into the footage to capture all of this at once.
Wow.
We're dealing with UTC time, universal time, folks.
Oh.
So I've got the recording, and they may go back there and they may delete this footage and put their own cartoon in like they did a few months ago.
Oh my, Scott, this is unbelievable what's happening here.
Yes,
We're
and
getting
ladies and gentlemen, this is happening right now. Ladies and gentlemen, listen to me. This is happening right now. Where you're standing on this planet, this is occurring. Now, like I said before, you may not feel it. You may not know it's happening, but listen, it is situations like this, what you're seeing on your screen right now. This is what is creating the massive amounts of earthquake activity, these deep earthquakes. Something is occurring inside of our planet. Something is causing our planet to basically expand. And these earthquakes are happening. The volcanoes are happening. We have over 35 volcanoes in full eruption mode right now. But look at this. I mean, you can clearly see, like the doctor was saying earlier, there seems to be an opening in the bow shock right there, there where my cursor is. It's flowing radiation directly into our planet, and I'm going to show you the radiation in live time that is now flowing into our planet.
Yeah.
So hold your breath, because you may lose your breath whenever you see this.
Yeah.
We're going to go ahead and look at the solar wind real quick, because I went back and I captured this just to make sure I captured it, recorded it before they deleted it.
Yeah. You see, that's the wave from the stellar wind from the other star behind the Earth. That's why it flicks like that. And that's a magnetic reconnection that you just saw going past. That's what's allowing the particles to get through the magnetosphere. It's just amazing what we're seeing. And don't forget, we have no real reason for the Earth to get hit in this way. All we have is slightly higher density, because we're going through a compression area in the solar wind. There's no reason why we should be getting extreme high densities at the bow shock and beyond. And we're getting continuous amounts of particles going straight into the magnetosphere. And that is because there are magnetic reconnections happening all the time. It means these particles are highly energized. And the only thing that could have energized them is the fact that they are colliding with the opposing.
Yeah, you know, something I'm noticing too is usually, you ladies and gentlemen, if you follow my cursor right here in the middle, we always see these reversing arrows. That is actually the reversing of the solar wind coming back towards the Earth from the opposite side. The length of these arrows in the model, they coincide with the speed and the intensity. But if you take a look at these little arrows where my cursor is, they're expanding in length. That whole mess that we just saw there, I can't even define what I just saw right there. But the intensity, as all of this energy is coming back towards the Earth, it's pretty far up there.
Yeah.
You can see the length of these arrows expanding, which means the energy is increasing. Now, we already saw a very considerable amount of earthquakes occur within a matter of hours all around the world. All around the world. And as soon as we're finished looking at these models, we're going to catch a quick update and see if anything else has occurred over the last hour and a half. I bet it has. And there were some very deep earthquakes, 460 kilometers deep. Doctor, how far does that put us into the Earth?
Well, that's definitely in the mantle, because the crust is only 100 kilometers maximum in depth. So that's 300 kilometers at least below the crust. So that's definitely in the mantle. And like I said before, you have these channels inside the Earth, I think both in the mantle and in the crust, where there's magma flowing. So the fact we're getting earthquakes so far below, it means the magma deep underground is moving. And when that happens, it affects what happens above that to a greater degree. So we can expect more earthquakes and larger earthquakes happening as a result of those deep earthquakes.
Okay, I have the solar wind prediction model, and the other day I did a video on this, and I was trying to warn everybody of what was about to happen, what we were going to be seeing. And this is it right here. Now we're on the 11th of June, and just everybody watch my cursor. These numbers right here, those represent the days on the calendar. This is a prediction model that normally goes out about a week. Okay, so here we are on the 11th. Here's the Earth, right where my cursor is. Now, I can't go back in time on this model, but when I was doing my video on this, we were watching this wave of energy coming directly towards the Earth. A definite impact. Well, everything that you just watched on the solar wind and the magnetosphere and the magnetopause models, this is what you're seeing. And this color yellow is elevated, right where you see my cursor. That is an elevated plasma density discharge that the Earth is going directly through. This impacted us, and it still is as we speak. Now, I'm going to go ahead and use my cursor just to inch this out ever so slowly. Now, once again, here we go again, Doctor. We're seeing this intensity after it has passed the Earth. And that, to me, once again, is suspect that these charged particles are coming in contact with another element. Helium?
Yeah, it's possibly is. The other day we were looking already that the solar wind was speed was down, and I saw that the electrons, I would have expected them to be higher because we saw high density already. And so my conclusion was there's probably more heavy ions in those particles than electrons. And so, yeah, heavy ions are, of course, helium and anything above that, lithium, so on.
So now I'm sorry, go ahead.
Yeah.
I was just going to say we're now moving past this point, but go ahead. I'm going to move this cursor back. Go ahead.
Now, don't forget, when we were watching the magnetosphere, when the bow shock goes out so much, it looks like the solar wind almost stops. That's why the bow shock expands outwards towards the sun. And that, again, to me, is evidence of this impact between the two stellar winds. The stellar wind from the other star is so strong that it actually almost pushes the solar wind from the sun back. And that's why the bow shock bounces towards the sun. So it's just amazing to watch this. It's just evidence of the fact that we have these objects in the solar system. These are stars that have, therefore, stellar wind. And this one seems to be producing it in waves. It's not continuous like the sun solar wind.
Well, I'll tell you what, I'm glad that I recorded this updated data.
Oh, yeah.
Because what I'm seeing right now, and let me stop this, I am seeing right here, right where my cursor is, everybody, you're seeing the bright pink and white. If you look over here to the scale, you see where my cursor is right now in this magenta purple color and the white. You are looking at plasma densities off the chart. Well, not really off the chart, but for us here on this planet,
yeah, it is.
And that's going to be impacting. I'm going to go ahead and back this up so you can see this. And please pay attention to this because, this is, you're seeing groundbreaking information right here.
Scott, the other day we looked at this and there was only one spiral with high density. I mean, now we see two of them. We see two spirals with high density. So things have changed. And these spirals are usually caused, it's a compression due to fast solar wind, and the fast solar wind usually comes from coronal holes, overtaking slow solar wind. And you get like a sort of a wave front in it, which forms that spiral. But now we have two. And the other day there was only one. Well, there was another one, but it was only green. It didn't look as dense as what we see here now.
Yes, it was kind of a lightweight. But now that I have the model back to the 11th, today. Okay, just before the 11th, you can see the planet Earth here, and you can see what is about to impact us. Okay, and this is occurring in real time, ladies and gentlemen. So here you go. I'm going to inch it up there. And there you go. We are just on the fringe of this. Look at the time scale over here between the 11th and the 12th.
Oh my.
We're less than halfway through the day in UTC time. And there you go. We're entering this right in the middle, just after tomorrow.
Yes.
So, ladies and gentlemen, what I'm trying to tell you is we're just in the beginning phases today.
Yes.
As each hour ticks on the clock, it's going to get worse.
Yes, it
minute
is.
by minute. Now, let's move on.
Yeah, there's something else that I see there, Scott, that's very interesting. You see the signet below, the radial velocity one?
Yes.
Do you see the orange below the ecliptic and the orange above the ecliptic?
Yes.
That means high speed above the ecliptic, high speed below the ecliptic, but where the Earth is on the ecliptic, it's much lower speed. And that, again, this is what we see. This is because the other star behind the Earth is slowing down the stellar wind along the ecliptic. So that tells you that this star is on the ecliptic behind the Earth.
Oh boy. Yeah, you're right.
Yeah.
I see your observation. You're spot on. Yeah, I really didn't pay too much attention to this lower signet down here. I was really paying my close attention up here, but that radial velocity, ooh, look at the spikes on the graph. Yeah, there's definitely some craziness going on, and
definitely,
I guess it's going to take us probably the better part of 2 days to get through this first wave, and then, as you see, that wave, it intensifies after it passes by the Earth on the 14th of June. And then between the 14th of June and the 15th of June, you're going to see this second wave. It looks smaller. Ladies and gentlemen, do not let size fool you. This second one is going to be worse than the first one. Pay very close attention how it has already intensified by the internal red color right here. Comparing it to the chart over here, plasma density, it's up there. But let's take a look and let's watch this just a little bit closer. Here's the impact. Look at the color. This color, this is bad, really bad. That puts us up all the way to about right here in our plasma density. Now, looking at the position of the Earth during this impact, moving over here, follow my cursor, past the 15th of June, halfway through the day, UTC time, look at the jump in the plasma density. It skyrockets. It's almost off the chart.
Yeah.
And then we're going to see a sudden drastic drop. But it doesn't matter about the drastic drop. Watch how the intensification right there, it really starts to intensify, getting into that magenta, pink, and white color in the bar graph over there. And there it goes. It's in, you know, then it ends. We'll have to wait another 24 hours to catch the date of the 17th and possibly the 18th, but the damage will already be done. The damage will already be done. And if you're looking here at the radial velocity on the same day of the 16th, you're going to see what the doctor was just talking about. Follow my cursor down here. You're going to see a huge velocity, radial velocity go straight up. Look at the chart over here. Sky high, almost off the chart. There it is, right there on the model. Now, that will be a glancing blow for the Earth. But ladies and gentlemen, these models aren't that precise. I mean, they're pretty damn good, but we could be right in this stream where that radial velocity goes sky high. That's going to be something to see. So basically from today through, I would have to say through the 17th and 18th of June. So for the next 8 to 10 days, possibly even another, maybe 8 to 12 days, we're going to be under intense, I guess like an intense threat of what's occurring. There's no doubt about it. Yeah, this is some very critical information. I can guarantee you that the earthquake activity will definitely increase. We will probably see a lot of auroras, North Pole, South Pole. We can possibly see them stretching down halfway through the United States. Again, we may see power outages. We may see cell phone issues and definitely internet issues. The biggest threat, ladies and gentlemen, in this type of occurrence is the earthquake and volcanic activity. We already saw the increase. It just popped off within a few hours, and we're going to go ahead and take a look at that. But before we do that, we're going to take a look at this radiation. And this is going to really worry you.
Whoa, look
I
at
actually
that.
went back. Yeah, I went back and I caught a few extra hours before, and I uploaded this and caught the new data.
Yeah, so this is the particles coming in from the night side because they're getting in through the magnetic reconnections on the front side at the bow shock, and they then being diverted backwards. And there's I explained this in the Aurora article, and now we see it. You see there's a large amounts of particles coming in through the night side.
Yeah,
so this
is just a complete envelopment of the Earth once again, and these are very heavy flows coming in.
So this is going to cause auroras, definitely.
Yeah, I'm going to go ahead and just ease this forward just a little bit so we can actually see. There it is.
Yes, large amounts of electrons coming in there.
Boy, this is pretty bad. And these colors, I've never seen these colors before.
No, that's maximum. That's above maximum. It's not even on the chart there. It ends at the red, but we're starting to see a pink there. So this is above what the chart shows. Because
so this is literally the definition of off the chart.
Off the chart. Yeah, they had to come up with another color that's not even shown there.
Yeah, they may definitely have to do that because I've only seen this a few other times before.
Yeah.
This kind of odd looking reddish color. And again, if you look over here, ladies and gentlemen, at the chart, the little rainbow chart right here, we're looking at this lighter color red, which doesn't even show up on this this bar graph over here.
Yeah.
Well, you can really see.
It's amazing.
And again, ladies and gentlemen, this is all updated data. This is fresh. This is not, from days before. This is right now.
And this is only the beginning.
Oh, yeah. It's going to get much worse. Much worse. I'll be monitoring all of this. Oh, my. I'm not going to get any sleep. I could see it coming. I could see a whole week to 10 days of nonstop monitoring all of this. And what did I want to show you? Oh, we already went through that. What was, the earthquakes. Yes. I wanted to get into that real quick. And we'll just go ahead and pull up and see if there was any updates on quakes since we left our last live stream. Oh my.
They
Oh
just,
my Lord.
yeah, so many. It's amazing.
This is not even the USGS. This is just one. My God.
Yeah. Well, if we see what's happening with the magnetosphere, then I suppose then we should expect more earthquakes.
Yeah, much more. Let's pan over here. They got all kind of activity going on over here. "63 minutes ago, the Ascension Island region, right off the coast between Africa and South America. This is going to reverberate. This earthquake's going to reverberate back and forth the energy. You know, Doctor, you may see another couple of earthquakes in your zone.
I was just thinking that's not far from Africa. We may see some in Africa again, and I wouldn't be surprised.
Yeah. Oh, look at that. Suspiciously, they removed the earthquake that went off right in the center of Georgia.
Oh my.
Remember we saw the earthquake here? It was a magnitude 2.43. Yep, they removed it.
Oh my. Right.
Let's see what's happening here in Arkansas, because there looks like there's multiple earthquakes right here north of Harrison. Magnitude 3.6 followed by a 2.37. Let's see what's shaking in California. No pun intended. Right along the San Andreas Fault. Magnitude 3.53. I can guarantee you that earthquake was bigger than that. They downscaled it. 2.68 Ridgemark, California. 2.78 Fraser Park. And then all of these smaller quakes. And what's going on up here in Alaska? What's this? Idaho. .2. There's a huge cluster of earthquakes here. Well, there's no doubt about it. The earthquake activity has definitely picked up. This is new 2 hours ago, magnitude 4.6 in the Philippines. And these were the very, very, very deep earthquakes over here in the South Pacific. I'm just making sure that there's nothing up here that we've missed. But ladies and gentlemen, that is the definition of earthquake activity. And this is the definition of what happens whenever we have these huge disturbances on the sun. You know, just the other day, ladies and gentlemen, there was another YouTube channel that was out there. I'm not going to mention any names, but they're out there telling you, oh, there's nothing to worry about. Scott's a liar. The doctor's a fraud. They don't know what they're talking about. They just want your money. Jesus God. Yes, ladies and gentlemen, you can clearly see we showed you the evidence as it was happening, as it was coming in. Devastating. Let's just hope that all of these earthquakes that we're seeing right now, let's hope and pray that they stay under a magnitude 6. But mark my words, as I'm saying this right now, I don't think that's going to happen. With what we're looking at, all of this incoming solar energy and the possibilities of something behind our planet that's producing an opposing solar wind from a brown dwarf star, there has to be something behind us. I don't care what anybody else says, ladies and gentlemen. I don't care what any other professional YouTube channels say. We're speaking with a professional physicist holding 5 degrees, masters, a doctorate, 17 years of teaching as a professor. I think she knows a little bit more than some guys on YouTube. And we're clearly showing you what is occurring, how it's occurring, and why it's occurring. This is Planet X News. We're going to be doing some live streaming starting tomorrow from my Nibiru channel, because we've been neglecting that channel, and there's a lot of other subscribers over there that really haven't moved over to this way. So let me tell you, if you're not subscribed to my Nibiru channel, get over there after this live stream and subscribe and set your notifications for that channel. Again, we're going to be also moving towards our X Factor radio station. And the reason why I wanted to bring up the X Factor radio is because it's not censored like YouTube is. We're able to reach every country on this planet. Now, there won't be picture shows, but the reason why I wanted the radio show was for you people, because I'm able to take call-ins. I'm able to provide you with a telephone number where you can call in, and now I'm giving you, the people, a voice to call in, ask questions, and interact with myself and the doctor and Chris Potter whenever he's on. I want to hear from you people. You are the people that count. So therefore, that was our next move, was the radio station, and we're going to be gearing that up ASAP, because I want to hear your voices. I see your comments. I know you as this avatar on YouTube, but I want to hear your voice. And I know that you want to be given a voice to speak and tell us what your observations are and what your concerns are and what your thoughts are. That's what this channel is moving towards, and they are trying to stop it. That's the bottom line. Everything you see, they're trying to stop it, but it's not going to happen. As we say, the show must go on, and that's exactly what we are going to do. We're going to take this to the world. We're going to take this on the road. Mark my words. Hopefully, if everything goes right, by the end of the Northern Hemisphere summer, possibly going into maybe August or September, you will see us. You will have the opportunity to meet me and the doctor and Chris Potter. You're going to have the opportunity to see us and hear us in the flesh. And we're all looking forward to meeting all of you also. So we're going to be holding these seminars and these conferences, and there we're going to have a bigger and broader spectrum where we're not going to be silenced. We're not going to be censored. That's the bottom line, ladies and gentlemen. I am sick and tired of the powers that be and these mega companies. I'm not going to mention any names because they'll cut me off the air, but they're trying to stop the flow of information. They're just trying to stop everything dealing with this subject matter. You can clearly see it. Ladies and gentlemen, once again, I was analyzing my behind-the-scenes analytics with my YouTube channels. I gained 1,000 new subscribers in a month, but I lost 996. So I netted 4. 4 new subscribers. What the hell happened? In 9 months of looking back at my analytics, I never saw anything like that. Now, all of a sudden, this is occurring as we get further and closer to the pinnacle. I'm not fooled by it. So, ladies and gentlemen, I ask you all the time, share the videos on your Facebook page. Share them on your Twitter. I don't care what you have to do, but we have to further the expansion of this information one way or another. I'd like to say a big thank you also to a whole host of individuals over the last several days that have made very nice contributions, financial contributions to this channel for the doctor, for her legal fund, for the lawsuit against Astronomy Live, for setting things in motion, for her losing her 17-year career at the university. Once again, that information, we're not going to talk too much about it right now, but we have a law firm standing by, and yeah, we have to pay them. But we're going to make this individual pay for what he did, because he had absolutely no right doing that. She wasn't hurting anyone. She did nothing wrong. So I'd like to thank all of you who have sent in your donations and your contributions. I really appreciate it, and so does the doctor. But we are still several thousands of dollars away from the retainer for the law firm, so we can set the slander and defamation of character lawsuit into place and stuff it right down his throat. And maybe he'll learn a lesson, and that lesson will be, don't put your nose in somebody else's business. And you caused a professional to lose her career because you're a little snot-nosed punk. I thank all of you from the bottom of my heart for your support. And once again, if any of you want to join in and help with the contributions or the donations, there's a PayPal link in the bottom of every single one of the videos. You can click on it. Hey, listen, I had one man send me $1. $1. Okay. He said, Scott, I'm retired, but I want to show you that I'm here. His name is Alfred. He was from Germany. He lived on a fixed income. I feel bad that, you know, he wants to be heard. So that man dug that deep to send $1. $1. Ladies and gentlemen, it's a cup of coffee. There's nobody else on the face of this planet that is stepping up to the plate like this professor, this doctor of physics is doing. Put her career on the line. We're all in this together. Don't ever forget that. It's us, not me. It's all of us. We're in this together. And this is a battle. This is a war against you-know-who. Because if they had it, if it was up to them, they'd wipe us all out. And that's what they're hoping on doing. FEMA camps. Give me a break. You won't catch me anywhere near a FEMA camp. You won't find me asking for help from any of those individuals. We'll do it on our own. We are the people. Doctor, any last words before we end this live stream?
Well, I'd like to say thank you, Scott, for your help, your support, and the people who support me. I'd like to thank them. And I would like to end with the way I usually end, which is to remind people that things are definitely happening, very serious things on Earth and in the solar system. And the best thing that we can do is get to know our Creator.
I agree. I agree 100%. You know, and ladies and gentlemen, you know, I mean, this isn't a big religious channel. I'm not a big religious person. However, I've already made my peace with my God, and it's the same God that everybody else has. We have one Creator. He may have many, many different names, but I've already made my peace. I made my peace whenever I took on this endeavor to bring all of this information, hopefully, to the world population, whether it kills me or not. So digging down, having that personal faith means a lot. It will mean a lot to yourself. And again, like I've said before, I hope one day that all of us could live in peace, but I also hope that I would have the chance at some point before this human life of mine ends. I'd love to meet all of you. I wish we could all have one big grand party, you know, like in a massive stadium, 75,000, 100,000, 150,000 people, whatever. It would be great. But getting back to that radio station, ladies and gentlemen, get over to the link in the description box for X Factor Radio. It's in the description box. Get over there, click on the link, set yourself up over there by following that radio station. Set up your notifications. It's very simple. We're going to be doing a lot from that radio station, and that is for you, because I'm going to give you a voice. And then we have the ability to do the live stream radio from X Factor Radio and live stream it right on YouTube. And that's exactly what we're going to do. This is Scott from Planet X News and our rogue physicist. I thank all of you for watching.